On October 17th, I was invited to speak at Invenio's SolidWorks Innovation Day 2026, an event celebrating the launch of SolidWorks 2026 and the creativity of its user community. The audience included designers, engineers, and educators, all there to see how SolidWorks is shaping the next generation of design, with special guest Sharon Toe, VP of Dassault Systems. In my talk, alongside 100 nervous umms, I shared the design journey behind Quadlock's cup holder mount, my most recent project. I highlighted the SolidWorks workflows that took the concept from early exploration to production, from master part modelling and design variations through to tooling preparation. Here's the full presentation, featuring real project footage, time-lapse modelling, and the final product in action. And at the end, a short introduction to speed modelling that I gave for the crowd here in Melbourne, Australia. If you caught this talk live, let me know in the comments.
Chris, thanks, Chris. Thanks very much, Becky. This one work. Thank you, Karim. Thank you, Invenio, for the day and for having me on. My name's Chris Berkner. I'm a certified SolidWorks expert, senior product design engineer, and design team lead at Quadlock. We design cases and mounts. I've got one here, another one up here, holding my phone recording right now, that our customers use to protect their devices during their everyday adventures. And today, I'm going to take you through the design journey of one of our latest products, the cup holder mount. So it's just going to run, and there's something I'll show a bit at the end that's a little bit different. It was a 12-month project. The product launched in July this year. The video I've captured was over 8-month period, 135 hours of screen recordings of SolidWorks work. So you may have seen those time lapses on LinkedIn in the past. I thought I'd take that to the next level with this. I've broken that into a few sections, showing some key elements of my process. So we started in April, early exploration of the project itself. At this point, not really understanding what the product is that we're designing. We have a stage processor called Quadlock when we go through certain gates to make sure we know what we're doing and that we're hitting the right marks for our customers. This stage is all about exploration. So we're actually looking at if there's potential partners we might partner up with. Sometimes we'll share our data, we'll get their stuff. We might be reverse engineering from supplier samples or integrating existing products. So import SolidWorks, modify the CAD, using assembly tools to make parts and learn about existing mechanisms. It's all about, at this point, like quick and low budget exploration, which we're trying to get to a point to settle on a direction for our projects as quickly as we can. Now, in this case, for this project, we decided to go down a path of designing our own product from scratch. And so here you can actually see the very start point of what is the cup holder mount and coming sort of to life. Now, I'm showing here my master part development process, and that's something that's been refined over my 18 plus years of using the software. Across multiple companies, but always as a product designer or a design engineer. I like to work with part files in multi-body modeling. That's my favorite way to start. And I create rather complex and evolving master sketches that drive all of the elements. And you'll see throughout this time lapse that I do come back to that sketch very regularly to make changes and adjustments as I'm learning about the project and refining the product as it's going through that development cycle. Those sketches, they drive all the key elements of the product. It's one or two that I have at the very top of the tree with driving things. The instant 3D tools in SolidWorks allow me to visualize those changes really quickly and move through, again, that process at pace. As I said, we've got that stage process. So we would have then decided, okay, we are doing our own product. We're doing the mount. We're using a certain mechanism, which is quite common on the market. So then we're moving into the design development stage. Now, the process that I've taken you through here in some of the screens, that process allows me to progress through the development stages at pace. So I've always got the ability to change track at any time, come back, make changes, make duplicates, variations, or proceed to the next level. So often I'll start in the multi-body environment, I'll split out to child parts, and then I can add draft, all thicknesses, assembly details, work on the clearances back in the assembly state. Using this workflow allows me to create, the primary geometry, split out using the insert part features for greater details or variations I enjoy the control, the level of organization that workflow affords me. And the process I've refined as well means that when I get to that point, say I'm trying variations in one of those child parts, and I find one that I like, if that's something I'm pretty set on and confident with, I can roll back those changes back into the master part, the skeleton, right? And then that will flow down to the next iterations of the design, the product. What you'll probably notice on screen, you'll start to see some elements that carry through design and other elements that get changed entirely. I think at this phase, we were looking definitely at the cup holder base element of the project. We weren't quite sure if it was going to have an arm on top or not. The quad lock system has a system of, we have the case that's separate, but then we have what we call heads, we have arms, and we have bases. And they're all connected with what we call our 360 system, which is that tooth interface you'll see on the top. So towards the end of this phase, we determined that it was going to be a full mount, and then we move on to the next step. So moving into sort of a detailed design and validation phase, obviously I'm not showing you any of the other background work that's going on. We are doing a lot of testing, we're doing a lot of prototyping, we're starting to work with our other partners in the other departments, marketing, etc., to make sure we're hitting the right angles. This is all focused on the SolidWorks. So in the detailed design, I'm starting to integrate our quad lock design language. We have a product range that has been around 10 plus years. We've developed a wide range of R products. We've developed a wide range of different arms and different heads. So we want to maintain cohesiveness of the products. And so this going into a car range where we have a windshield mount, we have a adhesive dash mount, we have a vent mount. We want to make sure that our products going into that area, they share elements, so it's not like there's this one that stands out from the rest. Everything's part of a one family of products. So at this point, we're starting to refine all of the details. So I'm really getting into some of the elements back in that master part file and making changes to some of the key geometry from the bottom up. And I'm making really heavy use of the rollback bar in those master part files. I like to keep a really clear feature tree as I'm working through, keep minimal areas. I find that's the best way to work efficiently. And some of the parts we'll start to see now in the assembly modes. I'm doing existing product compatibility checks. So given that everything that we have built for the company is in SolidWorks over that 10 plus year time frame, I can bring anything at any point to check and see, is this product going to fit with our other bases and arms, or are there going to be certain clearances or clearances that I need to be aware of? So I'm making heavy use of the assembly tools, things such as interference detection, to make sure that we're all clear to progress through those next steps. By September, so I think we're probably halfway through the timeline now. Style exploration, I find this a bit of a challenge. I do have leaned on other members of our team to sort of guide me. I've been at Quad Lock for 2.5 years. Some guys have been there for quite a bit longer. So helping them, getting their advice, and as a team working through to make sure that our products do fit that kind of design language. I worked on here a very high number of variations to this top component and knob. The constraints are set by the master part, so I knew where the thread was, I knew the outside diameter, I knew the top hole, where that's going to sit. But I had quite a amount of room to play with the design with the turning surface. I would have printed 30 plus versions before getting confidence we had the right outcome. We were looking for a design that will stand out in comparison to others, so competitors, but still fit in as part of our product family. So moving into the end stages, this is where scope creep can sometimes come into products. We made some changes along the way. In this example, we designed then a completely new arm to go on top of this product, and this was to be a gooseneck arm, so flexible yet strong. What I'm showing is a slight variation of the earlier master sketch part workflow. So the master sketch that was used to create the base, that actually didn't have too many versions. So yes, it did have a lot of iterations, but this one here, there were many variations because at the time that we were developing this, we were very quickly doing multiple prototypes with our suppliers because we need to do a lot of testing on this to make sure we're meeting the requirements of their user base. Very tricky element to detail and produce, but the master sketches, assembly visualization, drawing tools enable that rapid development. So hitting the endpoints here, so we're starting to work more with our manufacturing engineers and tooling suppliers. A lot of DFM reports back and forth, usually there with a combination of drawings and exporting of step files. And we're addressing the limitations of our design. So you don't want to obviously go through to the endpoint of your design, you sort it off and then find that you need to make all these changes to get it manufacturable. I'm quite keen, and we have a pretty good system now of including our manufacturing engineers and test engineers right from the start of our process. So here, I'm looking at particularly at this top element of the cup holder mount, where I need to address some thickness concerns in those walls. So I'm using the evaluation tools. I'm trying to make sure that we can core out that part, the inserts going to core out that material are not too small, yet at the same time I wanted to keep a certain aesthetic on the outside, a certain form. So a lot of back and forth with that analysis. And then last parts here, just a little workflow tip that I've sort of picked up over the years. When you're developing all these variations, you might get to a point where you've done it in one version, but there's something else you want to keep or change from one to the other. So I'll work with dual instances of SolidWorks sometimes, have the reference one open on one side, have the active part open in another one. There's a few sort of neat ways that you can work while that's happening to make it easier to bring detail from one version across to the other. All right, now we're about to jump into some of the last images of the product, and then we'll talk about something else that I've been doing a bit on the side for the last 2 years. So I want to shout out here to Trike Developments who assisted with this animation. The finished product has an expandable base with 3 grip lock legs. They extend to locking the cup holders from 70 to 100 millimeters in diameter. It's basically 95% of cars and vehicles out there. There's a blue ring which ties into the quad lock brand. It's got that flexible yet strong gooseneck arm, and our 360 feature interface allows for upgrades of the head to our wireless or magnet attachment ranges. And then shout out here to our world-class content team who create in-context videos you see. This product was designed with a variety of uses in mind to suit bumpy off-road terrain or everyday commuting. It can be used by drivers or passengers. Easy to install and use. It's tool-free, so no Allen key required to set up the product in your car. And the gooseneck arm makes the phone positioning a breeze. So none of the videos here really show it, but that gooseneck arm, it's flexible, but over bumpy roads, that's actually going to hold its position until you want to move it again. So many thanks to my team at QuadLock. It's not just one person obviously developing the product here, but a program manager, a manufacturing engineer, test engineer, content team, operations, everyone to bring this together. We do pretty well as a team to launch products so quickly. This one with a 12-month turnaround, and that's now selling globally. So that's the long methodical design journey, but sometimes design comes down to speed and efficiency. And that's where the speed modeling comes in. This was something Karim thought I'll show you about. Now, if you're a YouTube viewer, you may have come across his channel. This is Toby Schnars. He's the founder and website of the YouTube channel Too Tall Toby. He runs a community built on the gamification of CAD. Now, it's not specific to SolidWorks, but it's open to all CAD platforms. These are competitions to see who is the quickest, or what kind of software might be the quickest. It runs a live stream usually on Mondays. Is US based, so Monday night time. Watch a replay on a Tuesday night when I get home sometimes. And he has a World Championships. And you can see the sample there. This is a recording of me taking part in this championship last year, a live stream, which shows you a bit about what it's like.
Go! What is the total mass of this multi-body part or assembly in XXX.X kilograms?
This was the semi-finals.
That's going to be a heavy.
So they're starting to get, I think, to pretty high level of complexity now. I'm not going to show you exactly how long it took, although near the time lapse you can see the timer. So yeah, I challenge anyone out there to see, you know, how long you think it might take you to build that. This towel. Now, look, when I first came across the speed oiling, you know, I was a bit skeptical about some of the habits that people would use, but over time, once I was starting to see other SolidWorks users and users from other softwares compete and take part, I learned there was a lot of things I could take from that and bring that back into my everyday workflow. So clarity under pressure, mastery of features, it probably doubled my knowledge of shortcuts. You know, most people would know about mouse gestures and using the S key, that kind of thing, but there's a lot of other stuff out there that you can do. And through that, I built a real speed as a byproduct of that depth. So the same skills that let me model quickly under that competition pressure are what made me really effective in my day-to-day work. And that's how, you know, we can kind of progress our projects at quad luck. Yes, I'm one of the fastest users there, but yeah, how we're able to progress so quickly through the development cycle. So I won this one, got through the final. I got smoked by a guy named Rambo's Infusion. So yeah, that was fun. If you are interested in this kind of thing, the 2025 World Championships are happening right now, and they're down to the final four. I'm not in it this year, but there's a couple of SolidWorks users. The semi-finals happening next Friday, American time. If you jump on YouTube, search for Too Tall Toby, I'm sure you can find the channel. So that's it for me. Thank you again for hosting me today. I'd love to chat after this. Come say hi, or find me online at Fully Defined or on LinkedIn. Happy to chat. So thank you. Thank you, Chris.
Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.